This is Dr. Ravi Kumar Poluru, Assistant Professor working in the Department of Information Technology. So today's topic is evaluation of software economics. So today we'll discuss what is software economics and what are the different evaluations of software economics. So first we'll see what is software economics. Software economics is nothing but really we are going to check that the quality of the software. So based upon the assess of the quality, so that this will be impacting to the organization or not. So if the quality of the software is high, then this will be very impact to the organization, so that they can have the more profit of this software economics. So mainly this software economics having different criteria based upon we check. So software economics is nothing but it is the study and applications of economic principles in the context of software development, distribution, and usage. So here mainly they are going to verify the quality of the software. So what is the first initial stage of the development of the software, and what are the different types of the distribution means release 1, release 2, and the different types of the releases will be happening. And what is the usage will be impacted to the organizations. So here we are see main key points of the software economics here. The first one is cost of production. So mainly here the software development involves various costs such as labor, equipment, tools, and overhead expenses. So this cost will be analysis based upon. So we have the techniques that one is direct and another is indirect. So in direct method, so the labor, equipment, and tools will be having the more impact, and indirect such as the overhead expenses. It is again indirect method which will be calculating the cost of the overhead expenses will be happening while they are developing the software. The next one is understanding these costs is crucial for determining the pricing strategies and assessing the profitability of software products. So based upon this, they're going to calculate the cost, so that they're initializing what is the actual cost of the software, so that they can make them more profitable in the software products. This is the first step. And the next one is the demand and supply. So the demand for software products is influenced by factors such as the functionality and usability, performance, and price. So here the demand will be happen for the software products based upon the what is the main function they're using, and whether this code has having any arrays of the concept, and they're going to verify about the performance of the software. Finally, they're going to set the price of this software, and the software supply is characterized by factors like development time and availability of skilled labor and technological infrastructure. So this software supply will be having some important characteristics such as what is the durations of the development of software, and who are the expertise in this the skilled laborers during this schedule, and what is the infrastructure for this software to supply the demand and supply the software. And here the next point is the pricing strategies. So the pricing models for software products include one-time licensing fee period, and the subscription-based models and premium and usage-based pricing behavior. For example, when considering the Grand Prix, so there we can have the subscription base. This annually we need to pay, or sometimes based upon the impact, so that we need to take 1 month or a year quarter, so that the subscription may be happening. So there we have the different types of the premium values will be there. Based upon the usage, the price will be different, so that they're going to set whether we need to purchase the one-time license fee, or we need to subscribe based upon the users based data. And the choice of pricing strategy depends on factors like market demand and competitive landscape and target customer segments. So this price will be mainly differ based upon the demand which will be happen in the market. So the competitive with the software is more impacted and they're going to target the customers. So based upon the clients, so they're going to set the price here. And the next one is economics of scale. So software products often benefit from economics of scale. So where the cost per unit decreases as production value increase. So we need to this economics of scale will be having the impact to set the price of the software product. So we need to verify that various criteria to check whether we need to use the economics of scale or this economics of scale. It should be less than 1. The value should be, because when the process having very high value, means the production value increase, so the cost will be decreasing. And leveraging economics of scale can have software companies improve profitability and become more effectively in the market. So that they're going to verify that go to the different software companies will be how they're going to make the profit to target the market. And next one is life cycle management. So software products go through various stages in the life cycle, including the introduction, growth, and maturity and decline. So each and every stages they're going to check that whether the software having a more impact and having the performance is very high in each and every stages here. And next one is effective lifecycle management involves strategies for product development, marketing, and support to maximize revenue and profitability over time. So here in this life cycle, during this life cycle, they're going to verify the strategies to develop this product and targeting to the end users and the support to gain more profitability to the organizations. The next step is software maintenance and upgrades. So software economics also consider the cost and benefits associated with maintaining and updating software products. So here the software economics will be checking what is the cost and the benefits with maintaining updations and upgradations. Okay, so in each and every software products, so that based upon it, they're going to consider the cost and they're having the benefits in the organization. And here they have some factors for this one. The first one is the bug fixes and security patches and future enhancement contribute to the total cost of the ownership for software users. So each and everything. So when they release the software, so they're going to identify the bugs, so whether the bugs will be there and checking that how these bugs will be going to fix in the stipulated time. After that, they're going to release the patches. So these patches we can call it the security patches will be there. So each the updations will be happen, and moreover they're going to increase the number of features will be increased every patches they're going to release. Okay, so they're going to check the total cost of the ownership for the software users when they're going to release the different types of the patches in each and every release. Okay, so and the last one is here the risk management. So software development involves inherent risks such as technological obsolescence and competitions and changing the market conditions. So here mainly they're going to verify about the different types of the risk will be happen during the software releases and what is the new technology they're going to obtain. So based upon the technology they're going to check that what is the competitions in that, so that the software development will be happen only impacted with the different types of the mitigations and the migrations. So here what are the effective risk management strategies? Here will be happen is help mitigate this risk and ensure the long-term visibility of software business. So that they're going to update based upon the different types of the technologies. So whether they need to do the migrations or they're going to check that mitigate the risk. So here the updations will be each and every time they're going to verify the to scrutinize these security patches, and they're going to mitigate this risk to ensure that long-term viability of the software business. So these are the main key points of the software evolution of the software economics. Now we'll see in detail. There are some basic parameters are there to calculate the software cost are there. So the software cost will be mainly impacted based upon the direct and the indirect. So here we have the software cost model can be abstracted into a function of 5 basic parameters. So there we have the 5 parameters are there. So based upon these parameters, they are going to estimate the cost. So one is size, next one is the process, next one is the personnel, next one is environment, and the last one is the quality. So here we have the size of the end product. So mainly we need to check that what is the size of the product. So how they're going to check that the size? Size is mainly based upon the number of instructions, the source instructions, or number of code, or we can call as the number of function points will be identified by using the quantified in the software software developing the during the initial stage of the functionality. So the size of the end product in human generated components, which is typically quantified in terms of number of source instructions. So there we can call as the SLOC, okay, or we can use the number of function points will be there. So that based upon these 2 criteria, whether SLOC or the function points, so that they're going to check that what is the main requirement to develop the functionality in the software. The next one is the process. The process is mainly used to produce the end product. In particular, the ability of the process to avoid non-value adding activities, such as these like rework, bureaucratic delays, and communication overheads. So they should be mainly they're going to try to avoid. For example, in 2021, the Tesla, they have released the cars. Okay, so they have faced some enormous problems. Is front view is the main problem. They have recalled 3 lakhs, nearly 3 lakhs cars. They have recalled. Yes, they are doing the rework of the cars. Okay, and mainly they are happening the delays. Delays will be much more happen, and the communication is overhead will be happening during this time. So before the deployment, they need to verify each and every things, and then only they're going to release the products into the market. Or else, when this process cost is very high, then this total, it means the software product cost will be diseconomic. So we need to minimize this cost of the process. The next one is the capability of the software engineering persons, and particularly their experience with the computer science issues and the applications domain issues of the project. So they're going to verify about the different experience they have faced in the computer science, and what are the different types of the applications domains will be there for the projects. The next one is environment. So which is made of the tools and the techniques. So mainly this environment, so while they're developing the software, they need to check that what are the different types of the tools and the techniques they are going to available to support efficient software development and to automate the process during this development of the software. So the main required quality of the product include its features, performance, reliability, and adaptability. So mainly we need to check that the quality of the product. So for each and every product, mainly we need to check the quality. So how we can measure this quality means based upon the features. What are the more number of features will be available in the software? and what is the performance and reliability and the adaptability. So not only this, we can have the availability and the capability. So these are the main features of the quality of the any software product. Now we'll see the what is the main relationship between these parameters to estimate the cost. So here we have the effort. So here we have the effort is equal to the personal, means the persons will be there, so that they are going to have the experience in the computer science and having the issues of the project. And environment means the tools what they're going to use here, the techniques, and the quality. So the quality have the different types of the metrics, so that for the number of features, the performance, reliability, capability, availability, adaptability, so like that. And we have the size. So size is very important for here for the estimation of the cost. So it is based upon the source line of code, or you can call it as the instructions when you're checking the software development, or the number of function points. And here we have the power of the process. Okay, so based upon these 5 parameters, we are going to calculate the cost of the software product. So here one important aspect of software economy. So here this software economies will be happen based upon the criteria of the process. Okay, and here, so as represented with the today's software cost models, that the relationship between effort and the size. Okay, if the size and the effort, so it means it will be having the diseconomy of the scale. It means the cost of the product will be very high. So how we are going to check that whether this is the economy of a scale or the diseconomy of a scale? So the diseconomy of a scale of the software development is a result of process. So mainly it depends upon the process. So if the process is greater than 1, then we can consider it is a diseconomy of a scale. So here it means the most manufacturing process, the more software you build, the more expensive it is per unit item. So that we need to check that whether the software is a software economies or diseconomy. So that every time we need to check that the process should be less than 1, not greater than 1. If it is a greater than 1, then we can consider as a diseconomy of a scale. So here in this picture, so we can have the 3 types of generations are there for the software economy leading to the target objective. So here the first one is, here we have the x-axis and the y-axis. So in the x-axis we have the software size, and the y-axis we have the cost, and we have the 3 types of the generations will be there. This is the first generation, second generation, and the third generation. In the first generations, so they have developed the waterfall model. So we have seen that waterfall model is they have developed in the era from the 1960 to the 1970, and they're having the functional design. So mainly it will be impacting the functional design and having the diseconomy of scale. So why the waterfall model consisting the diseconomy of scale? Why means the cost of the project or the errors or the bugs will be identified only after completion of the all the SDLs, that is software development lifecycle. Okay, after each and every stage's completion, then only they are going to identify what are the hurdles which will be happen during the project. Okay, so here what will be happen during this stage means it will be over budget and over schedule. So that's why each and every period of time they need to review whether the project they're going to allocate is smoothly running or not, or else it will be having the over budget and the over schedule. Because in waterfall model, each and every stage of the process or the phase completion only, then it will moves to the another phase of the process. So that's why the environment or the tools which you're using in the waterfall model is a custom. The size is 100% custom. The process is ad hoc, so that they cannot estimate what is the actual budget in the waterfall model and what is the schedule. So whether they are going to complete the project within the stipulated time or not. That's why the main challenging task in the waterfall model is over budget and the over schedule will be happening. The next one is here we have the OTS. OTS is nothing but of the shell. Okay, so this developed in the era of 1980s to 1990s. Process improvement is happened here, and they have used the encapsulation based. Okay, so even though they have improved the process, so the main challenging task is this economy of the scale will be happening here. Why means they have allocated the 30% of the component based and remaining 70% of the component. So the process is repeatable here, and the challenging task in this OTS is infrequently on budget on schedule. It means the unpredictable of the what is the budget and the schedule during this stage here. The last one is the software ROI, that is return of investment. Okay, from the 2000 onwards, this iterative and development has been implemented, and the component based they are used, and the return on investment. So here, what is meant by return on investment? So return on investment is nothing but what is the net profitability by investment. So that is what we can call as the return of investment. It means how much gain based upon the investment. So this is the modern practices which are used here. So they have implemented the off the shelf as well as the integrated. So here they have used the 70% of the component based and 30% of the custom they have used, so that they can easily manage and measurement of the what is the budget and what is the duration of the schedule of the project. So this in this era, this generation, they are going to predict the what is the budget as well as what is the schedule of the project. So this is the best practice, having the 70% of the component based in the third generations. So here we have the three generations is divided into conventional, transition, and the modern practice. Okay, so there the project performance in the conventional, the project performance was highly predictable. So that based upon the cost, schedule, and the quality objectives. But they have the underachieved means in the waterfall model. So they're not going to identify in each and every stages what are the challenges and the issues will be happen during the stages and the transitions in the 1980s and the 90s. So the 30% of the components will be used here, and the 70% of the official tools will be used here. Here they're going to use the higher level programming languages. So, but even though, but they're going to unpredictable of the budget and the schedule. And next one is the modern practices from the 2000 onwards. So they have used the 70% of the components and a few of the custom builds they have used. So this is very easy to predict the what is the budget and the schedule of the project. Okay, and mainly the organizations are achieving better economics of scales in successive technology eras with very large projects, long lead products, and lines of business comprising multiple similar projects. So we have discussed return on investment. So what is actual definition of return on investment? So return on investment, or we can call it as return on cost, is a ratio between net income and investment. Okay, it means what is the net income they have achieved and what is the initial investment, so that they are going to calculate the return of investment profitability. A high ROI means the investment gains compared to its cost, means they are achieving more profit during this stage. As a performance measures, ROI is used to evaluate the efficiency of the investment or to compare the efficiency of several different investments. Okay, so here we have the three different types of the return on investments are there. So the first one is line of business life cycle, that is successive systems. Okay, so initially they are going to use the investment in the common architecture, the process, and the environment for all the line of business. So here initially they are going to more invest on the architecture and the process and the different types of the tools. Okay, and here they're going to check that each and every in the different stages, like first system, second system, till nth system, and they're going to verify the what is the software ROI. In the second, achieving ROI across the project with multiple iterations. So they're going to use the robust architecture, means different types of the blueprint of the software project and mature iterative process. Still, they're going to modify any components like hardware or the software, and the process automations, whether they need to use the automatic tools or the technologies. Okay, so each and every time they're going to release the different types of the iterations of the software, the blueprint of the components. The first iteration, second iteration is the nth iterations. The next one is achieving the ROI across a life cycle of a product release. So here the last stage is nothing but the release of the software products. So investment in product achievement and lifecycle release process and process automation. It means the completion of the product achievement and what is the different types of the releases they're going to use. It means it will be evaluating the deployment and the maintenance will be happening here. So after the deployment of the software, they're going to release the first release of the software, and next batch of the software, that is second release, till end release, so that the software they're going to calculate the software ROI here. Okay, so these are the reference I have followed for this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.